Okay, so this is going to be the video for lesson 3.2. The actual lesson got some issues with it, so this is just a recording with nobody in the room, no class, so there'll be no questions from students. We're going to start off by completing the diagram to determine the product. So this will be called using algebra tiles to multiply monomials by polynomials. You'll be expected to also use these types of diagrams and algebra tiles to do polynomials by polynomials. Remember, monomial means one term. So we have a monomial there, 2, and we have a polynomial means more than one term. And that's a binomial because it only has 2 terms, that x plus 1. The single blocks here and here, those represent just 1. So on the top we have 1 plus 1 is 2. That's our monomial. And on the side we have 1x, and we have a 1. And that represents our binomial that we have in the brackets. If we multiply these in, we see an x goes there, and an x goes there, and single ones come in here. So we got that by multiplying this x by that 1 gives you 1x. Another x by another 1 gives you another x. 1 and 1 gives you 1, and 1 and 1 gives you 1. That gives you your final answer, so all you do is you count just everything that you have here in the middle. And what we have there, we have 2 x's, plus we have 2 single things. So, 2x plus 2. We jump over to this side, we do the same thing. So, sorry, I gotta switch to the arrow. An x times an x gives you an x squared. And now we have a different thing here that you'll notice we have a negative. So that negative 1, because it's not shaded in, represents this binomial here, the negative 1. When we multiply a negative by a positive, we get a negative. So this negative 1 times this x right here will give you negative x's. So not shaded in. Not shaded in is negative x. Our final answer, we have an x squared here, an x squared here, so we have 2x squared. And here we have a negative x and a negative x, so we have minus 2x. Down here, example 3, we're actually going to sub in our monomial and our binomial. So we have negative 3. We'll put those along the top. And then we have x minus 1 along the side. So it's a positive x minus 1. And then you just do the same thing. So positive x times negative 1 gives you negative x's. And then negative 1 times negative 1, that gives you positive 1s. So that'll be your answer. So we have negative x, and negative x for negative 3x. And then on the bottom we have 1, 2, 3 plus 3. If we move on to the next question, we have to try to take the product. So we know the answer in here. And we want to try to draw what it came from. So we know it came from a monomial and a binomial. Since we know we have an x squared, the only way we get x squared is if we multiply 2 x's. So we're going to put an x on the top, and we're going to say it's positive. Which means this has to be a positive. This has to be a positive. And how do we get this negative x? We have to go x times a negative 1. So it's just an empty box. Now diagram 2 over here, is asking you to solve it in another way. It's the same question. You see you have your x squared, and you have your negative x. Another way we can get these positive x squareds is if we were to multiply two negative x's. So the first one will be a negative x here, and you know you have to get another negative to get a positive, which means this is positive down here. That means the same answer came from two different questions. This one on the left was x times 2x minus 1, and this one over here was negative x times negative 2x plus 1. Two different questions gives you the same answer. Now we're going to move on to the distributive property. The distributive property is another way of solving monomials multiplied by polynomials. But you'll also see it later on when we do polynomials by polynomials. So this is just kind of a beginner step to more advanced questions. You see up here we have our little property. It's an example using variables. You're going to take whatever's on the outside, your coefficient, and you're going to multiply it in to get that a times b and a times c. So let's jump right into an example to show you what I mean. We're going to take this 4, and we have to multiply it in there, we have to multiply it in there. Also known as distributing it in to the brackets. When you distribute it into the brackets, 4 times 3 is 12, x is still x, plus 4 times 1 is 4. Move over to b. This will get a little trickier. We see that our coefficient, our number in front of the brackets, is a negative 5. So the negative has to also distribute in. So the whole thing distributes in once, twice, 3 times. Negative 5 in the first time, negative 5 times 2x is negative 10x squared. Negative 5 times x, the second time we bring it in, is minus 5x. And negative 5 times negative 6 gives you positive 30. Wonderful. So here on C, we see that our coefficient is actually behind the brackets. Does that make a difference to how we handle this question? No. No, it does not make a difference. We could put that x squared in front or behind. Its multiplication order does not matter. So when we have it behind, that's okay. We distributed it in the exact same way. So x squared times x cubed. You add the exponents because it's multiplication. That becomes x to the power of 5. And x squared times negative 2 becomes negative 2x squared. Finally, we have another tricky one because our number that we're going to distribute in is a negative, but it's also a variable. So we have to handle that a little differently, multiplying variables. We multiply our negative 3x. We multiply it in the exact same way to all 3 terms inside the brackets. Negative 3x times 7x. So take your coefficients, your numbers, multiply them together. Negative 3 times 7 gives you negative 21. Then take your x and multiply them together to give you x squared. You do the same thing. Take your negative 3 and multiply it by negative 2. That'll give you positive 6. X times y, can we combine those? How do we handle that? So, when you multiply 2 different variables by each other, you can't add or subtract or do anything with the exponents. You just write them in as x times y. Just like that. That's all you can do with them. You can't simplify it any further. Finally, we do negative 3x times z. That'll be negative 3xz. And that is your answer. Finally, we're going to go on to a little more difficult questions. So we see it says expand and simplify. Expand. Expand means distribute in. So if we look at this first question, it's telling you to distribute that in. And then simplify means bring together your like terms. So this negative sign right here that we can't see because I've covered it. This negative sign, it is attached to that 4. So you have to distribute it in with that 4. So the entire thing goes in. The 6 in front of that, it just remains there. So you're going to have 6 plus. It's going to be plus now because we're going to distribute our negatives in. So 6 plus negative 4 times 8 gives you negative 32x. And negative 4 times 1 gives you negative 4. So what do we do when we have plus a negative? Well, it's just like subtraction. So you now have negative 32x. And we combine our like terms. Our like terms are negative 4 and 6. So we combine our like terms to be plus 2. We're going to do the same thing here. That 4 is going to distribute in. That negative 2 is going to distribute in. So it'll become 8x minus 12 plus negative 2x plus 12. That plus 12 comes from negative 2 times negative 6. The two negatives combined give you positive 12. Combine our like terms. We see a like term here and here, and we see a like term here and here. If we go 8x minus 2x, we get 6x. And then negative 12 plus 12 gives you 0. So we just leave it as 6x. These 12s cancel each other out. Finally, we have this one over here. We see that we have a negative, but no other number in front of those brackets, just a negative. So you have to pretend almost that there's a negative 1 right there. And distribute that negative 1 in. That'll help you remember that that negative applies to both the 4x and the 3x squared. So distribute that 5x in as well, and you should get 15x to the power of 3 minus 35x squared plus 5x plus negative 4x minus 3x squared. That negative 1 distributed in to give you that negative 4x and negative 3x squared. Now we need to combine like terms. X cubed is right there. Our x squareds are right there. And our x's are right there. 15x cubed. Combine your x squareds to get negative 37x squared. And combine your x's to get negative x. And that is your answer. Finally, we have determined an expression for the area of the given polygon. Now, there's a couple ways to handle this. I'm going to show one way, and others may know other ways. That is okay, as long as you're getting the right answer. So the way that I'm going to show it is we don't have an expression to find the area of an L. This looks like an L, right? It's kind of a tilted L, but that's okay. It's a big box missing this big chunk in here. So we can't just use our regular formulas. what we have to do is create a couple more boxes. So, we're going to draw a dotted line right here. And this creates an area here that we can calculate. And it calculates an area here we can calculate. In order to do that, we need to know what this side right here is. What is that side length? Well, that side length is, we know this entire side length is 4x. We know this little part is 2x. So the missing part must be 4x minus 2x. That missing part is 2x. Now it's really easy. Now we have two rectangles. It's easy to calculate the area of the rectangles. If we just calculate the area of this green rectangle and the area of this blue rectangle and add them together, we won't have a problem. So we're going to extend the page a little bit. To calculate the area of the green rectangle, we need length times width. The length is 2x. The width is 3x plus 2. And we need to add the area of the blue. So the blue is 2x times x plus 5. We solve that equation. We solve the area of that weird L shape. So expand the first one. This 2x is going to go there, and it's going to go there. Sorry, it was 2x plus 2. I forgot my plus sign. Distribute that 2x in, and you should get 6x squared, and you should get plus 4x. Multiply that 2x in there and there, and you should get plus 2x squared plus 10x. Now you have to combine like terms. Those are like terms there. Those are like terms there. And when you combine those like terms, you get a final answer of 8x squared plus 14x. And that is the area of our weird little L-shaped box. That concludes the lesson on how to distribute monomials into polynomials.